Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Will Sweet.
Thanks, William. And thank you, everyone, for tuning in. Our next iteration of the case study series. For this one, we're going to be talking about an application where we help the customer revalidate. So revalidate an actual successful cleaning process where they were cleaning PCBs in an Aqueous Inline. Again, they were successful, but when new technology comes out, there's always ways to try to look at and to continuously improve and make more efficient your processes that you already have in-house. So the opportunity in particular, this customer was a Class III Military and Aerospace assembler. Again, at least what we're talking about today, it's all just with printed circuit boards. For the past 6 years, they've been successfully cleaning no clean and OA solder paste and flux residues in their inline washer. And then for us, again, they were successful, but with them staying in contact with us and us having a good relationship, we let them know that we have a newer generation cleaner, and they allowed us to come in and benchmark the current process against our newer generation cleaner to see if we could make any improvements to their process. So the challenge, determine if this next generation cleaning chemistry can achieve the same, if not better, cleaning results. And this is, of course, without compromising any compatibility or any adverse effects to their cleaning process. As long as they're getting the same, if not better, cleaning results, we want to help them out in another way. So we want to make their process more efficient by potentially lowering concentration or giving them a longer bath life. The process. So again, only the cleaning agent was altered. That is the only thing. All of the other variables were held constant. So the temperature was held the same in both conditions, the same belt speed and nozzle configuration as well. And for this particular inline spray machine, they have an Intermix spray manifold. So what that means is they have both fan spray and coherent spray nozzles. But just to reiterate that both conditions, so both their older chemistry and this newer generation chemistry, were ran through the exact same configuration. Wherever the nozzles were placed in the machine, both of them went through the exact same condition. So the way to bank success on cleanliness, at least, we use 3 different methods. For their particular spec, for production, is actually a visual spec. So their circuit boards have to be visually free of any flux residue, as long as it meets their ROSE test as well. So yes, we made sure that both of those specs were passed, but we also added SIR testing, surface insulation resistance, just so we can get a little bit more specific on the cleaning levels of each condition, because you can go a little bit deeper when it comes to SIR. The process parameters. So the top right picture on this slide is exactly how the boards were placed in the machine. They were in a basket just like that with a lid. And as you can see, at the bottom are the different PSIs. Anybody that does any inline cleaning probably already knows this, but you want to make sure that your bottom PSI sprayers, or the bottom PSI is not as strong as the top PSI. That's just because you want the top sprays to keep the boards down onto the bottom of the washer. So yeah, as you go through it, you can see the different sections of the wash, the different sections of the rinse and the dryer, keeping at 140 F for both conditions in the wash and moving to 135 for both conditions in the rinse. The process, so what we're looking to improve to make this a worthwhile changeover, if they were to change cleaning products at all. The current product, I guess I should say, that they are using is a pH 10. And then we're looking for a different pH, and actually this newer generation as well. Currently, they're running at 13 to 15% concentration. That's their working concentration. And we're looking to at least get them down to a 10 to 13% concentration. So anybody that does inline cleaning already knows that a couple percentage points can actually be a lot of chemical savings. So, I mean, if you just think about it this way, a 100-gallon washer, you're going to have to fill that up with 15 gallons of chemistry to get it up to a 15% concentration. If you bring it down to 13, you're already saving 2 gallons on each fill up right there. And that's not even considering any evaporative losses, any makeup chemistry that you have to add to the machine to hold the concentration constant, anything like that. So, and then when it comes to temperature, they're running at 140 degrees Fahrenheit. We want to be at least that, if not a little bit cooler than that. They're running at 2.5 feet per minute. Again, we want to be at least that, if not a little bit faster, to shorten that process time. And then right now, their bath life is 4 to 5 weeks long, and that equates to about 85 to 90 pump hours. And so in the same sense, we want to get to at least 6 weeks of bath life so that they can start saving some chemistry. Then in both conditions, they clean a water-soluble paste and a no-clean, so we're going to be cleaning the same types of residues as well with this newer chemistry. So the visual inspection after the test has been completed. Before washes on the left, you can see some of that white residue in between the leads on the QFP. And then on the right, everyone knows it's tough to, with the naked eye at least, to see if a circuit board is actually clean or not. So we went in with a microscope at 100x, and you can see this a little bit better. And those are those same leads that I drew attention to a second ago. And there is no white residue after the wash with this new chemistry. And then these are the SIR results for the qualification. So this was original testing with a clean bath. There's no flux residue that has been accumulated in that bath yet. So again, everything is reaching clean levels. This is what that not only the customer, but we would consider as clean. And then fast forward all the way to 12 weeks. And this is at the point where we say that the boards are failing and it is time to dump and recharge your bath. So we were shooting for at least 6 weeks of bath life, but we ended up actually getting 12. So we overshot our goal, and that's great news so far. Then, of course, compatibility. We just had to make sure that there were no negative effects when it came to the current compatibility, and there were none. So with all of their labels and things like that, we sent their labels through up to 3 times in some cases, and there was still no degradation or color change for any of their labels. And then process improvements. So with this new validated condition, this new cleaning product, the pH is now of that product is 8.7 as opposed to the 10 that they were running. Their old concentration was 13 to 15%. We're able to decrease that to 9 to 10%. So lots of chemical savings, and there's several percentage points that we are not having to use anymore. The temperature is still at 140 for the new condition, and that's again, this is a parameter that we're looking to at least keep the same, if not improve. And the same goes for the wash cycle. They're still running at 2.5 feet per minute. It did not take any longer to get these parts cleaned. And then bath life is the big difference here. They went from 4 to 5 weeks, or 85 to 90 pump hours, to 12 weeks, or 310 pump hours. So that is huge savings over time. Almost 3x, almost 3 times the savings, or 3 times the bath life that they were getting. And then, of course, it was the same soils that we were removing with the old product and the new product. And then conclusion, overall, the objective was achieved. This newer generation cleaning product is actually called our AQUANOX A4727. And the cleaning process was the same. So there, we're not losing any cleaning whatsoever with this new product. However, we're able to lower the working concentration by several percentage points. And again, that's just savings right off the top. We're able to increase bath life by almost 3 times. And that's also a lot of chemical savings. And it is also a lot of waste savings. So you're not having to dump as frequently. So you don't have the sheer amount of volume that you did have before of the waste. There were no rinsing issues. Similarly to the compatibility section, we just wanted to make sure that there were no issues we were bringing to the table. There were none when it comes to rinsing. So overall, lower cost of production. You're not having to use as much chemistry. You're not having to throw away as much chemistry, and overall higher yields. So we would say that this was a very successful reevaluation. We're able to save the customer a lot of money over time, and a lot of money over time without actually hurting anything else in their process. So we're making them more efficient with this new cleaning product. Then moving on to frequently asked questions on this topic. How often should I look at reevaluating my cleaning process? And it's tough to put a number on that, especially with how many variables there are out there in the manufacturing environment. But I would just say stay in contact with your chemical supplier, and they will let you know when they have new technologies that they're able to release to market. So there is that old adage of don't fix what's not broken. It's still something to pay attention to, but there's also always ways to improve what you're doing and make your processes more efficient. So let your chemical supplier let you know when there's something new out there, and if you have time, maybe it's a good time to start looking at new options that they have to see if it can make your process more efficient. And could reevaluating ever backfire? Short answer, I'd say no, because if you're doing it correctly, you test. So it's not like you're just introducing a whole new product into your manufacturing environment. You're testing to make sure it's going to make sense, make sure that it's actually going to benefit you, whether it's going to make you more efficient or save you money, what have you. So as long as you do that beforehand and you prove it out before putting it into your actual production, then it should never backfire. And finally, what if I don't have time to reevaluate? Similarly to the first FAQ, keep in contact with your chemical supplier, because if you don't have time to take your process offline and test yourself, a lot of these chemical suppliers and machine manufacturers, for that matter, have labs and have the environment that they are able to test for you, and they can kind of reevaluate for you and see if it even makes sense. And if it makes sense, then you can take further steps to potentially test in your own facility. And with that, I will pass it back over to William.
Thank you, Will. Thank you guys for tuning into this Tech session. If you would like to discuss this topic further or have any questions that were not answered during this session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kyzen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.